Hello friends, hope you are having a fantastic day today. In this video, we are going to learn a very important coding pattern called two pointers. This is a really powerful technique in any coder's hand, and if used correctly, this can improve your code significantly. Not only that, this technique has been really popular on many technical interviews, and all big and small companies, they love asking these kind of questions because immediately if you use two pointers, you can bring the time complexity from big O of n square down to big O of n, which is a significant improvement. And in this video, I'm going to show you that how two pointer technique works, how to identify it, on what kind of data structures it is being used, and I'm going to give you three different examples of actual lead code problems that has been asked by I don't know, hundreds of companies. So stay tuned, and first let's get started with what a two pointer technique is. So the most basic definition of a two pointer is that it is a way for us to iterate over any given array or any given linked list. In either kind of a fixed data structure, if we use two pointers, this would be greatly helpful for us to traverse over the given input. Now, there can be multiple ways we can input over the given array. So one way is that our starting pointer is located at the beginning of our array and our second ending pointer is located at the end of our array. Now what would happen is that maybe after every single iteration, it could be possible that both our starting and ending pointer keep moving towards each other, or it is also possible that in one iteration only the starting pointer moves to the next element, on the second iteration the ending pointing moves towards the other way, and there can be many considerations we can keep on whether the traversing direction sets or not. Now the traversing ends when the starting and ending pointers are about to cross each other. When that happens, then we can conclude that now the traversal of the array is done, and whatever the answer we have calculated, we can return that as the answer. So this is one way to use two pointers. Second way to use two pointers is that we have a starting pointer and we have an ending pointer, maybe located few steps ahead of the original starting pointer, and sequentially we keep on moving from one step to the other step depending on the input. So this is also another way to use two pointers. Now as I mentioned earlier, two pointers is typically used with array and linked list, but sometimes you can also use it with strings as well, because strings is also a set of different characters and that are just bunched up together. So these are the three data structures where typically you would consider using two pointers. Also one more thing, sliding window and two pointers, they go hand in hand because both of them typically allows you to iterate over the given input arrays, linked list or string in some way or shape, and combination of both of them is going to be very crucial in many coding problems that you will see. So I hope this explanation makes sense. When we move on to the examples, things would become much more clear on how we are implementing the two pointers technique. So the first example we are going to see is going to be the 2 sum 2 problem. This is a really popular problem on Leetcode. This is an additional variant of the original Leetcode number 1 problem, the 2 sum problem. And how it is different? It is different in a manner that given input array is sorted in this case. Now, if you want, you can go ahead and read out this whole statement, but I'm just going to explain you that what the problem is giving us and what the problem is asking us to do. Basically, first of all, we are given an input array that is sorted. So that is great for us. Now we are also given a target value, and our ask is to find that whether there are any pair that exist that sums up and whose sum becomes this target value. If that is the case, we need to return their index values. Now, as a part of added complexity, typically array index values start from 0, 1, 2, 3, something like that. But in this case, we are being told that we need to use one index array. Hence, you see the value starting from 1. So this is just a minor thing, not a big deal. This is very easily done. Now, the next thing we are being asked to do is that we need to find the solution for this problem without using any extra space, which means space complexity has to be big O of 1. This is a really big ask, and this is going to make a lot of things very interesting. So first, let's see that what could be the different ways to solve this problem. Well, first idea that comes to our mind is a brute force approach. And what we can do in a brute force approach is that we take the first element, we consider that can this first element be part of the target value that makes this value number 11. If that is the case, what is the value we need to see? We need to find value number 9. So what we are going to do is, for this value number 2, we will check in the entire array to see whether value number 9 exists or not. Once we identify that value number 9 does not exist, we are going to move on to the next value. Now we are at value number 3. If we are at value number 3, which means for target we need to have value number 8 present somewhere. So again, we will check that whether value number 8 exists or not. Lucky for us, in this case, we found out that value number 8 is exactly here. And the moment we find out, we need to return the index values of both of them. So we can return the value as 2 and 5 in this case. This is the answer. So brute force solution gives us the desired answer, but the thing is the cost is pretty high. Why? Because for every single element, we are essentially iterating over all the other remaining elements to get the answer, and that puts the time complexity to big O of n square. That is a very bad time complexity, and we have to aspire to do something better. So let's see what could be the better approach. Well, one approach comes to our mind is that since this given array is already sorted, why don't we use the benefit from this sorted property? And what is the benefit from this sorted property is that we can actually use binary search in this case to identify any single value. This is a huge improvement. How? What we are going to do is, again, same as brute force, we are using the same approach. So first, if we consider that if this 2 has to be part of the solution, then there must be a 9 existing in the remaining array, because we are told that the target value is 11. So we need to check that whether in the remaining array does value number 9 exist or not, because first value we are considering is value number 2. This we can do very easily using binary search, and we can complete this whole task in basically log n time, nothing more than that. And this is a huge improvement. Now if we keep on applying the same logic, what would happen is that first for this value number 2, we would identify that okay, 9 does not exist in log n time. Now again, for this value, we will try to see that whether 8 exists or not. Since 8 already exists, we would be able to return the solution pretty quickly, and basically we would be able to do the whole thing in terms of time complexity. Everything would be done in n log n time, because n is like the number of elements that are given over here, and log n is to do binary search on the remaining part of the sorted array. So this is also a very good approach, but there exists a better approach than this. So let me first quickly show you that why two-sum solution won't work here. Because original two-sum solution we were using a hash map, and in the hash map we were storing the values that we have already iterated over, and then it became really easy for us to find the target value. But in this case, we are explicitly told that we need to find the solution using only constant space. So space complexity has to be big O of 1, hence we should not consider using the exact solution from two-sum problem. So now let's come back to our main issue, and let's just find the most beautiful thing, that is the two-pointer concept. What we are going to do is we are going to have a starting pointer at the beginning, we are going to have an ending pointer at the end. Now we know what we are trying to do is there can be three possibilities. First possibility is that if we do sum of both of these values, the sum could be greater than the target value. That is one possibility. Second possibility is that sum could be less than target value, and third possibility is that sum is exactly equal to the target value. The moment we identify that the sum is exactly equal to the target value, awesome, bingo, we have achieved our thing that we wanted to do. But if in any case we identify that whether the sum is greater than our actual target sum, if that is the case, what we need to do is we will need to bring the overall sum down, and for that we are going to iterate our ending pointer on the left side, because that way the overall sum would come down, because all the left values from this end pointer are guaranteed to be lesser than whatever value we have over here because of the sorted property. So this is a huge thing we need to consider. Same way, in this scenario, if we identify that given input is actually less than whatever the target sum is, then we need to update our start pointer to move one step towards right, because that is how we would be able to increase our sum of the starting and ending indices, and it would bring us closer to the target value. And the moment we reach to the equal phase, we can return the answer immediately. So let's see this in action. First, if we check, okay, starting and ending pointer, if we do the sum of these two values, it's going to be 12 plus 2. So the sum is going to be 14. 14 is actually too high. Since 14 is too high, we will have to move one step towards left. So again, now we are going to be at the position number 6 or index number 6 where the value is 10. If we again do the sum is going to be 2 plus 10, it is going to be 12. 12 is still greater than value number 11. So again we are going to move our end pointer. So now our end pointer is located at this position after 2 iterations. If we do the sum, it's 8 and 2. So 8 plus 2 is actually 10. Now we are in this less than scenario. So because of that, we will have to update our starting pointer. So now our starting pointer would be located at this position number 2 or value number 3. And now if we do the sum 8 plus 3, we are going to get the value as 11, which is exactly what we wanted. So in this case, since we find the answer, the index positions of starting and ending pointer, we can return them as the answer, and the answer in this case is going to be 2 and 5. And this is a wonderful way to solve this problem. Now if we see time and space complexity, in this case the time complexity is actually going to be big O of n, which is the best time complexity of all the approaches I have shown you. And space complexity, well, apart from using couple of variables to store as pointers, we are not using any space complexity. So this is going to be constant space. This is a huge improvement compared to all of our brute force approach or our binary search approach. And this is what actually shows you the power of using 2 pointers to iterate over the given input. Now you see, we were using array, and we identify that at any given position we will have to do comparisons between two values. And since the property was sorted, it makes sense that either we are going to move in one direction from left to right, or we are going to move in the other direction from right to left. And here 2 pointer makes a good sense to use. Let's move on to the next example. Now for the next example, we are going to use one of the most popular problems on Leetcode. This is the problem called container with most water. If you see, this has been liked almost 23,000 times. So this is a hugely popular problem, and this is a Leetcode medium problem. So if you want, again, you can read this whole given input, but I'm going to skip that, and I'm just going to explain you using the example. So basically we are given an input array. Now this is not sorted or anything. There is no such property as that. But what we are told is that any single value inside this given array represents the height of that particular element, or a building, or a bucket. You can call it whatever you want to. Now what we can do is, based on the height difference, we can create some common places. So if we consider this value number 1 and value number 2, based on this we can see that we can actually make a bucket that looks like this. Now we cannot make a bucket that looks like this. Why? Because the height of the smaller item is only 1. So this is the only bucket we can make using these two items. Now we are already told that this is already one edge of a bucket. So there is no way that water is going to leak from here. There is no way that water is going to leak from all of these places as well. And we can only fill water up until the point where the smaller edge is located, not the higher edge. Same way, if we want to consider a bucket between this value number 1 and 3, the biggest bucket we can make is going to be of size this one. And this is a way for us to store water in our container. So basically this becomes our container. Now the idea is that we need to find a way to store the maximum amount of water in liters in our container. Now how can we find a maximum amount of water? Basically we need to find a maximum container that can be made. Now the shape of the container is definitely going to be a rectangle in this case, because of the positioning of all the edges. Since it is going to be the rectangle, basically we need to find the maximum area rectangle from these given graphs. And the rectangle, we can only consider the smaller height to be consideration in order to make a rectangle, or calculate that how much water is present at any given position. So the idea in this problem is that we need to find that where we can store maximum amount of water, which means that where we can find the biggest container, or that is of rectangle shape. Now what is the area formula for a rectangle? The area is pretty simple. It's going to be length multiplied by height. Now in this case we have a way to calculate the length, and that is through these index values of this given input array. So this indicates that what would be the length between any two indices. And at the same time, for height we are already given the values, but when we are considering the height between any two places, we are going to consider the smaller height to be considered as the edge for our container. Now, I hope this explanation makes sense and our purpose also makes sense. So in this case, if we see the maximum water we can carry is going to be between this bucket, because if we see the area of this particular bucket, that is going to be the maximum area. Now first, what is going to be the height we are going to consider for this area? The height we are going to consider is going to be 3, because this is the height of the smaller edge. The length in this case is going to be 4 minus 2, so length is going to be 2, and the total amount of water we would be able to store is going to be 6 units. So let's just consider, because it's water, we can consider it to be liters. So 6 liters of water we can store in this container, and this is the biggest container or maximum amount of water we can store. So let's try to see that what could be different ways to solve this problem and how we can use 2 pointers to find the optimal solution. And for that, I have actually drawn a much bigger problem, and this is going to help us visualize the problem, and also at the same time we would be able to make some interesting suggestions. So what is going to be the most simple brute force approach? Well, most simple brute force approach is pretty common, that we take, suppose we are making a container using this value, then we see that what are different possibilities of all the containers we can make, and what are going to be the different areas of all of those containers. At the same time, we are going to have a max variable, and that max variable is going to keep track of what is the maximum area we have calculated so far. So first we would take all the containers using this value number 1. Then we would take all the containers using this value number 2. So we would make a container like this, then we would make a container like this, and then we would make another third container like this, and depending on the positioning, we would keep on making the containers. Every single time we would be recording the maximum value. This is guaranteed to give us the correct answer, but again the solution is going to be big O of n square, which is not what we want. We want something smarter, better, faster. So what could be the another solution? Now, unlike the previous explanation, in this case you cannot use binary search, because definitely there is no sorted property, or there is nothing to be searching for. Essentially all we need is a way to find maximum amount of water. So let's see how we would be able to use 2 pointers in this scenario. Again, as always, we are going to have our 2 pointers. So first pointer is going to be located at the first position, so this is going to be our starting pointer, this is going to be our ending pointer. Now between the starting and ending pointer, what we are doing is, since they are so far away from each other, they form the maximum length possible. So length portion we are already considering to be the highest length, and since they are going to come towards each other, the length is slowly going to decrease. But what would increase is the height, because there are different height positions or different height combinations, because over here a single height makes no difference. We need to worry about the combination of any 2 heights, and that is going to give us that how much amount of water we would be able to store. So in this case, height would be the variable factor. Since height is the variable factor, why don't we make our traversal decision based on the height? And how we are going to implement height as our traversal decision is that first of all we are going to check that what is our purpose. Our purpose is to find the maximum area. Maximum area can be maximum only if either the length is maximum or the height is maximum. So the only way we are going to move one step to the left or one step to the right is by keeping the value with higher height constant and the value with lower height to move to the next value. And this is how we would be able to find the maximum container value. Still confused? Let me quickly show it to you through a live demo. So in this case, we are going to have a max variable that is going to keep track of maximum amount of water we have calculated so far. Currently, the difference between these two, the length is going to be 8. If we see height difference, we are going to choose the minimum height amounts to. So this is the minimum height, which is 1. So the area is going to be 8 times 1. So maximum area we have found so far is 8. That is acceptable. Now in this case, is it more beneficial to move the end value towards left, or is it more beneficial to move the starting value towards right? Obviously, it is more beneficial to move starting value towards right. Why? Because this value is already smaller. So there could be possibility that in future, if we get a greater height, and we keep this bar, this edge, then we could have a bigger container. But if we move on the left hand side, again the maximum amount of water we would be able to fill is going to be determined by the smaller height that was initially located. So in this case, since S is located at the smaller position, we are going to update the position of our S. So currently now S is located at value number 8. So this is the height and this height is 7. And again now the length is going to be 7. What is the maximum amount of water we would be able to fill? It is going to be, we would consider this height to be 7. So 7 times 7, it is going to be 49. 49 is greater than maximum. So we would add 49 as the answer. Now again in this case, it makes more sense to move the ending pointer because the height of this one is greater. So now we would move, since we are moving it over here. Now again this value is decreased, and then we are going to consider another water between this portion, and that is going to be 3 multiplied by 6, so that is going to be 18. This is not going to be the maximum, so again we are going to move to the next value, and for the next value again we are going to move it to the value number 7. So this is going to be our end variable, and then the height is currently same and the distance in this case is 5. So this is going to be 8 times 5. 8 times 5 is going to be 40. 40 is still not greater than whatever the maximum amount we have found so far. So again we are going to keep on repeating the same process, and eventually we would come at the position where starting and ending position are next to each other, and they would be able to cross each other. That moment we would stop our traversing. Whatever the maximum water we have found so far, we would return that as the answer, which in this case is going to be 49. That is superb. That is the most wonderful way to solve this problem. And if you see what we did, we basically use 2 pointers, starting and ending pointer. If we see time complexity, in this case the time complexity is going to be big O of n, because we are simply iterating over the given input array once, nothing more than that. If we see space complexity, even the space complexity is going to be big O of 1, because apart from using like 3 variables, we are not using any additional space or any additional data structure to store the space. So this is a very wonderful way to solve this problem. And that is how we are going to remove duplicates from the sorted array. Now all of the previous 2 questions I mentioned, I have already solved them on my channel, so I didn't show that what companies have asked that problem, but they are really popular problem. For this one, the Leetcode problem number 26, if we see some of the popular companies who have asked this question, there are companies like Apple, Facebook, Amazon, Microsoft, Google, Bloomberg, LinkedIn, and Intel. They have all asked this question. So that is why this is a really important question. And let's just quickly go through that what is the problem statement, and then we would try to make the solution. Now in this case, if you want, you can again read this whole thing. I'm just going to explain it to you quickly. The problem we are given is that we are given a sorted array. That is cool. Always love when the array is sorted, makes things life so much easier. Now in this case, we are told that it could be possible that sorted array can have duplicated entries. So the moment we identify duplicated entries, we don't care about all the duplicated entries, but the thing we care about is that in the initial portion of the array, all the distinct values has to be present. All the other values, we can mark them as anything like X or underscore or hash or whatever you want. We don't care about those values. So in this case, we are given an input array with 7 characters. But if we see the number of distinct characters we have, we only have 0 as a distinct character. Then we have 1, 2, and 3. So 0, 1, 2, and 3. These are the only distinct characters we have. Now for these 3 characters, we don't care anything. So we are not going to mark them. Basically, they were duplicate entries and we are not concerned. But in this case, we are concerned with the distinct characters. And the moment we find the distinct characters, we need to put them at the beginning and then return whatever the solution we have been able to find. So what is the brute force way to do this problem? Again, brute force way is pretty simple. We just take one value and we will try to see that, okay, how many duplicates there is one, and then we add that, then keep on repeating the same process. And then if this is a duplicated entry, again, we move on to the next value. So this approach is guaranteed to give you the answer in big O of n square solution. So brute force is always not a good way to go. The next way to go is that we can actually try to do something smarter here. And what we are going to do is, obviously, this is a 2-pointer solution. So of course we are going to use 2 pointers. But since we are using here 2 pointers, we are also going to find a way to store the index value. So we are going to have an index value and we are going to initialize it with starting position 1. Now this first value is guaranteed to be a distinct value because we are told that there is at least one value in the array, and that value has to be part of the original distinct value. So we are going to directly put it over here, and that is why we put the index pointer at value number 1. Now index pointer is just a way for us to iterate over, and also these two pointers, what we are going to do is initially they are both going to be located at the same place, but the end pointer is going to move few steps ahead till it finds a new distinct value. That is what it is going to do. So in this case, currently starting and ending pointer, so this value is same as this one, so we need to skip this part. So we are not going to care about this value, we are going to move to the next value. Now our starting and ending values both are located at this position. This is a distinct value. The moment we find a distinct value, since we find the first distinct value for this index position number 1, we are going to add it over here. So we add value over here. The moment we add the value to our array and we find like a new distinct value, we are going to do index plus plus. So now our index value is going to be 2, and the next distinct character we find, we are going to add it to position number 2, which we find immediately. We find it because this is a new one, because the end pointer went there and it didn't find any duplicate values. So again 2 comes over here and our index value gets updated to value number 3. Now we currently the scenario is that our starting and ending values both are at the same position. So currently the starting pointer is located over here, ending pointer is located over here. Now this ending pointer is going to go one step further. So currently ending pointer is at value number 2. Again, this value number 2 is the same as the previous value. Since it is the same value, starting pointer is going to remain here. Ending pointer was here. It didn't find anything. So now ending pointer will go to the next value. Next value is a distinct value. Again, distinct value, starting and ending pointer becomes at the same position. Index value becomes 4. And the value we added to our input. So we added value number 3 to our answer. Now again at position number 3, ending pointer go to the next. This is already 3. Now ending pointer tries to go to the next. Array ended, so we can't do anything about it, and this we can return it as the answer. We don't care about these values because that is none of our concern. But you see, even in this case, rather than coming on one side, starting and ending pointers were working in tandem to go from one step to the other step to find the answer. This was an easy problem, and in this case I intentionally chose this problem because we are at the same, apart from using two pointer solution, at the same time we are also using sliding window technique, because we are creating a window between starting and ending pointer, and the moment we find some solution, reasonable solution, we shift our window depending on the conditions. And this is a beautiful way to solve this problem, and that is why I decided to keep this solution at the last. So I hope this explanation makes sense to you. I know that explanation is the one part, but you have to practice on your own in order to master all of these techniques. So please go ahead, practice as much as you can, and let's hope you find this useful in your day-to-day life or your coding interviews. Thank you.